All right, welcome back to Everything Mathematics, and let's do this today. Today we're going to speedily move on to rule number 2. Yesterday we looked at rule 1, in which it states that if we have the product of two logs, we can add the single entity of each one, and vice versa. If we add in two logs, we can simply find the product of a single one of them, granted that the base is the same. Today, the rule is very similar. It's just that we're not adding. Instead, we are subtracting. So the rule today says, rule 2 says that if you have, for instance, log A of B minus, if you got yesterday's one, today's one will be very easy to grasp. If you have log A of B, so log base A of B minus log base A of C, this would be the same as, since the bases are the same, which is A in this case, put log, that's a bit log. This is the same as log A of B divided by C. So in essence, the log A remains the same, the base remains the same, but the first one, it becomes a fraction, let's put it like that. So the first one becomes the numerator and the second one becomes the denominator. And that's basically rule 2. Of course, this could go the other way around. So if I have something like log B of, let's say, Q over T, this is the same as log B. So I have my log B. Keep writing P for B. Oh my goodness gracious. So this is the same thing as log B of Q, the top goes first, minus log B. Oh, wow, I did it again, of T. I did it again. I wrote a P instead of a B. Oh my, I'm doing that since yesterday's video. B. So yes, the bases remain the same, and you simply take away the numerator from the denominator. So it's either way, it's either you make one a fraction and you keep the base, or if you go to expand it, you keep the base again, but then you subtract each log. Basically, that is what is taking place here. So let's do a 2 example again. And like the previous rule yesterday, you can ask here to do the same thing. You could ask to expand, and you could also ask to write as a single. But I would go into simplifying instead. Since we know yesterday's rule and we know today's rule, we could start getting a little more creative. So let us simplify. And by simplifying here again, I don't want it to solve. If I wanted to solve, you're going to get the answer. But we're not solving, we just simplify. In this case, sometimes you have to expand, sometimes you have to retract. So if I have something like this, log of, let's say, A, let's stick to algebra, X minus log of what? Let's say A of T. And then we have plus log of A and what? Let's say we have X, we have T, let's use Y. What if you have to simplify something like this? And I know this might look like one of the hardest things, like, whoa, boy, we jump straight to that. But again, it's just a matter of applying the rule. Again, you have to be able to see the single entities of the various logs. So this is one for itself, one for itself, one for itself. And we just apply the rules. So we could use the first one first, because that's the simple one to just write in one line. So if you go to simplify this here is the same as, and you will write this like this. We have applying rule 1 here, because we are adding, we have log A of X minus log of A of T. Now I'm writing F for T, of Ty. Good. So log A of X minus log A of Ty. Or did I get Ty? Remember, I am adding 2 logs. So that's the same as multiplying the logs. We're finding the products. And here now we could do rule 2, because we have one log entity being subtracted by another log entity. And here we will finally end up with log A of the numerator is the first one, X, all divided by Ty. So you see, it just looks complicated to start with, but if we apply the rules, we could break down any complicated question as easy as this. And as I said, when you do more rules, that's when things get more interesting because you have to know how to apply the various rules when dealing with different questions. Let's try another one. Let's try another one. So supposing we have something like, let's say we have, let's use numbers this time. So we have, let's say, log 3 of 5. Well, I don't know if that's even possible. Of course it's possible. Log 3 of 5 plus, let's say, log 3 of 6. And let's subtract that from maybe what? Log 3 of 10. Let's simplify this and see what we get. So first thing first, of course, we look at the log rules. We add in these first two logs. We are subtracting it from this last one. So let's add first. And I advise you, yes, whenever you have addition and subtraction, add first. Even when you do most rules of, what you call this, order of operation, addition usually takes place first. I've never tried subtracting first, but if I do, I believe the answer will end up being very much complicated. But more than likely, you still end up with the same thing anyway. But it's just that you end up working with a fraction earlier than maybe you should have. Right. So here, if we add first, again, in keeping with rule 1, we would have, let me change mine into blue. So we have log 3, and I'm multiplying these two things, the 5 and the 6. So that will leave me with 30. So log 3 of 30 minus log 3 of 10. Yes? And now we have these two being taken away from each other. So here we could apply rule 2. So here we did rule 1. So this here, let me just bracket it out. Here, we applied rule 1, the rule that we learned yesterday, rule 1. And here now, we could apply rule 2 because we are subtracting. So this will be log, maybe I should, let me leave it in blue. I've got to write it in red because this is the final answer, but we have log 3, the base remains the same, and now we have 30 divided by 10. Good. And this is consequently equal to log 3 of 3, which, believe it or not, is actually equal to 1. And this is actually a log property 2 or a log rule, one of the cancellation rules that we will definitely learn either later this week or maybe next week. I'm not sure where this rule will fall. I don't know how much days we are remaining in this week anyway. Oh, I think 2. Today's supposed to be Wednesday. Right, so yes, log 3 of 3 is equal to actually 1. And this is one of the cancellation rules that we could use whenever we solve in a log. If we end up with something like this, we could always just replace this with 1, which is what it's equal to. Or if you cannot see it like that, remember what we've been doing all the time. We raise to the index to give us this. So if we raise 3 to the power of 1, we will actually get back 3. So yes, it's something that we could use to substitute. And when we're looking at the laws of indices, 3 raised to the 3, we could simply, once the bases are the same, remember we could just equate the powers. And yes, indices also come in handy in these logarithms shenanigans, if you should put it like that. So yes, I think that's basically in a nutshell rule 2. And I took the opportunity one time to punch on rule 1, because again, in keeping to what I said yesterday, this could only get more interesting the more rules you add to them. You would not be tested on an isolated rule. Maybe unless if ever it's a multiple choice and they just want to see, they want to test a specific rule. Maybe so it might be possible. But other than that, generally, you have to know the various laws of logarithm, the various rules in order to solve questions dealing with logarithms. So that will be the end of today's video. As always, feel free to like, share, and subscribe if you haven't as yet. And if you have any question, of course, feel free to contact me or put a question in the comment section below, and I will be sure to answer as soon as I see it, as soon as possible, because I check daily and regularly. In fact, I actually get notifications. So yes, until then, you take care. Enjoy the rest of your day.